Today we will learn the pictograph. You must have seen data represented in the form of picture, object, or as a part of object in newspapers or TV. This representation of data is called a pictograph. For example, this graph shows the consumption of petrol in India in 3 different years. Similarly, the estimated production of crop in the year 2017-2018 in India is obtained from this pictograph. Similarly, the pictograph shown here shows the number of viewers watching different types of channels on TV in a village. Here, the number of viewers of the news channel is represented by 3 pictures. Here, since the value of one picture is 100 viewers, we can say that the number of people watching the news channel in the village is 3 multiplied by 100 viewers is equal to 300 viewers. 5 full and 1 half image have been used to represent the viewers of the entertainment channel. Since the value of one full picture is 100 viewers, we can take the value of half the picture as half of 100, that is 50 viewers. In this way, the number of viewers of entertainment channel will be 5 multiplied by 100 viewers plus 50 viewers is equal to 550 viewers. Similarly, can you tell what will be the number of viewers of science channels? Think. Let us tell you, this will be 4 multiplied by 100 viewers is equal to 400 viewers. Similarly, the viewers of sports channel is 450 viewers. Information can be obtained just by viewing the pictograph. As most of the pictures here are in entertainment row, so we can say that among all channels, the highest number of viewers are of entertainment channels. The difference in the number of viewers of science and sports channels is represented by half picture, which represents 50 viewers. Can you tell us the total number of viewers of entertainment and sports channel? Think. Let us tell you, a total of 9 full pictures and 2 half pictures, that is 10 pictures, have been shown for entertainment and sports channels. In this way, the total number of viewers of these channels will be 10 multiplied by 100 viewers is equal to 1000 viewers. Similarly, solve the question by yourself. Which channel is least viewed? Give reasons. What is the difference between the number of viewers of entertainment channels and sports channels? What is the total number of audience or viewers in the village? Now, you must have understood the pictograph. So today we have learned about pictograph. In the next video, we will understand it better with some interesting examples. Today we will see some interesting examples on pictograph. The monthly expenditure on various items of Ravi's family is given in the following table. Represent this in a pictograph. Let us draw the pictograph from the given information. Here we have to take appropriate value of symbol so that we can represent all numbers correctly. If we take the value of the symbol as 500, it will make it easier for us to represent all the numbers. House rent is equal to 3500 rupees. Since the value of one picture is 500, to show 3500, we have to make 3500 divided by 500 is equal to 7 pictures, which we will make in this way. Similarly, 3000 rupees has been spent on food. Therefore, we will represent it by drawing 3000 divided by 500 is equal to 6 pictures. Now, can you tell me how the expenditure on electricity can be represented? Think. Absolutely right. We have to draw 1250 divided by 500 is equal to 2.5 pictures. Similarly, for education, we have to make 2500 divided by 500 is equal to 5 pictures, and for others, we have to make 1500 divided by 500 is equal to 3 pictures. Next example, the students of a school were asked about their favorite activity and the data received was represented in the form of pictograph. Read the pictograph and answer the questions. What is the value of one picture in a pictograph? The value of one picture in a pictograph is 5 students. If the value of a picture is kept 10, then how will be the number of students who like to listen to music will be represented? Since the value of the picture is 5, we can say that 6 multiplied by 5 is equal to 30 students like music. If the value of one picture is taken as 10, then we have to make 30 divided by 10 is equal to 3 pictures. Which activity do the students like most? Seeing the pictures, we know that the students like watching TV the most. What is the sum of numbers of students who like to hang out with those who like to play? 4 multiplied by 5 students is equal to 20 students like to hang out, while 6 multiplied by 5 students is equal to 30 students like to play. Their sum is 20 students plus 30 students is equal to 50 students. Now you can find out the answer to the following questions by looking at the given pictograph. What information is given in this pictograph? What is the difference between Rohan and Tina's marks? Write the name of students with highest and lowest marks. If Rohan would have got 50% marks in science, then what percentage of marks did Manish get? Similarly, find out in which months the birthday of students of your class falls and represent the information obtained in the pictograph. So today we saw some interesting examples related to pictograph. Today we will learn about bar graph. You must have seen the bar graph many times. Like here, this represents India's literacy rate in percentage. Looking at this, we can compare the literacy rate of given years. The elevations of various mountain peaks of the world are shown in this bar graph, so that we can compare them. Similarly, the result of the State Assembly election of State A is shown in this bar graph. Looking at this, we can compare the seats won by different parties. Let's understand this bar graph. In this bar graph, there is a horizontal line which we call the x-axis and the vertical line that we call the y-axis. Here, party is on the x-axis and the number of seats is on the y-axis. Simultaneously, the scale is also shown here, which tells us that 1 unit on the y-axis means 10 seats. The vertical lines of uniform width are drawn at equal distances. These are called bars. All the bars in the bar graph are of equal width and have the same distance. In the bar graph, the data is represented as the length of the bar. Thus, the graphical method of representing the data, in which data is represented by horizontal or vertical bars of equal width at the same distance, is called bar graph. Let us now know how to read a bar graph. Here we see that the length of bar made for party Q represents 56 seats. In this way, we can say that in state assembly elections, party Q won 56 seats. Similarly, can you tell how many seats the party R has won? Think. Absolutely right. For the length of bar made for party R, we know that party R has won a total 54 seats. The comparison of data becomes easy with the help of bar graph. As the maximum length bar has been drawn for party P, here we can say that party P has won the most seats. Can you tell how many more seats did party Q win than party S? Think. Absolutely right. We see that party Q has won 56 seats while party S has won 44 seats. Therefore, party Q has won 56 minus 44 is equal to 12 seats more than party S. Here we have shown a vertical bar graph. We can also represent it horizontally, wherein we show the parties on the y-axis and the number of seats on the x-axis. We call this bar graph the horizontal bar graph. Now, let us know how to draw a bar graph with the help of an example. The table shown here shows the lengths of some of the major rivers in India. Let's represent these data as a bar graph. Draw two mutually perpendicular lines on the paper. The horizontal line is the x-axis and the vertical line is the y-axis. Now we will show the names of the rivers on the x-axis and the length of the river on the y-axis. Now we will choose a convenient scale. Can you tell which convenient scale shall be taken to show the length of the river? Think. Let me tell you, the longest length here is 2900 kilometers and the shortest length is 800 kilometers. In order to represent both correctly, we can take a convenient scale in this way. We can take 1 unit is equal to 500 kilometers. The number will show numbers on the y-axis according to the scale. Now, we will draw the bar according to the length of each river. For example, here we have drawn a bar denoting the length of Narmada river at 1300 kilometers. Similarly, we will represent the lengths of all rivers as bars. Remember that the bars should have the same width and should be equally spaced. So today we have learned the bar graph. In the next video, we will see some examples of these. Today we will see some examples related to bar graph. In a school, measurements of children's shoes were taken for the annual ceremony. These are as follows. Represent the given information in a bar graph. Let us assume 1 unit is equal to 20 students and draw a bar graph based on the information with a given scale. On the paper, draw the horizontal line x-axis and the vertical line y-axis. We will show the shoe measurement on the x-axis. Similarly, we will show the number of students on the y-axis by taking scale as 1 unit is equal to 20 students. Since the maximum value is 108, we will end the number of students on the y-axis at 120. Now we will draw the bar in vertical for each measurement of shoes whose length represents the number of students. In this way, we will draw the bars for all measurements of shoes. Thus, we have drawn the bar graph for the given information. Next example, the bar graph shown depicts India's performance in the Asian Games. Read the bar graph and answer the following questions. In which year India received maximum medals? The longest bar in the bar graph has been drawn for 2018. Since the number of medals is denoted by length of the bar, we can say that India received the most medals in the year 2018. How many medals did India receive in 2010? From the length of the bar drawn for the year 2010, we know that in 2010, India got total of 65 medals. How many more medals India got in 2006 as compared to 2018? In 2006, India got 53 medals and in 2018, it got 69 medals. There is a difference of 69 minus 53 is equal to 16 medals in the number of medals received in the both years. Calculate the decline in the number of medals from the year 2010 to 2014. India received 65 medals in 2010, while in 2014, 57 medals were received. In this way, from the year 2010 to 2014, the number of medals has fallen from 65 minus 57 is equal to 8 medals. Next example. In 2017, a survey was conducted in India to know the number of newspaper readers. The details of some highly read newspapers are shown in the bar graph. Read this number and find out the answer to the following questions by yourself. Which newspaper has the most readers? How many people read the Hindustan newspapers? How many people read the Lokmat newspaper? What is the difference between the number of readers of Dainik Jagran and Lokmat? So today we have seen some examples related to bar graph. In the next video, we will see some mistakes related to them. Today we will see some common mistakes related to bar graph. The teacher made the table shown on the board and asked the students to represent it as a bar graph. On this, a student made the following bar graph. Find out what mistakes the student has made in it. Mistake 1. The width of the bars in this bar graph is not the same. Mistake 2. The distance between the bars in the bar graph is not equal. The distance between the bars in the bar graph is always equal. Mistake 3. The x-axis and the y-axis are not named in this bar graph. For this reason, there is difficulty in understanding what information the bar graph shows. Here, the roll number on x-axis and digits obtained out of 10 on the y-axis should be written, with the help of which we can read the shown bar graph properly. Mistake 4. The scale of this bar graph is not shown. Here, we need to take a convenient scale such that we can take 1 unit is equal to 2 marks here. With its help, we can thus show the marks obtained on the y-axis. This will help us to read the bar graph properly. Thus, in this bar graph, we have found the mistakes. These mistakes can be removed and the bar graph can be drawn as follows. Do not make such mistakes while drawing a bar graph. Today we have seen some common mistakes related to bar graph. Today we will learn double bar graph. Let us understand the double bar graph with the help of an interesting example today. The number of boys and girls admitted to class 8 in different years in a school is presented in this table below. Can we represent these figures as a bar graph? Think. Let me tell you. Here we can draw different bar graphs for the number of boys and girls, but it will be difficult to obtain information from these. For example, it would be difficult to know which year had the largest difference in the number of boys and girls. It will also be difficult to determine which year the total number of class 8 was highest. In such a situation, a double bar graph is helpful. In this, we represent two sets of data on the same graph as pair of bars. In the pair of bars, one bar represent one group of data and other bar represent another group of data. Let us know how this double bar graph was drawn for the given data. Step 1. On paper, we will draw two mutually perpendicular lines, year on x-axis and number of students in class 8 on the y-axis. Step 2. For our convenience, we will choose a convenient scale. Like here, we can take 1 unit is equal to 20 students. According to the scale, we will show numbers on the y-axis. Step 3. For showing the number of boys, we will take color of bars like this, and for showing number of girls, we will take bars of this color. Step 4. Now we will represent the data as a pair of bars. To show that there were 60 boys and 80 girls in class 8 in 2007, we would draw the bar representing number of boys 60 and with this also, and draw the bars representing number of girls 80. Similarly, we will represent the data of all the years in the form of double bar graph. Remember that we will keep the width of the bar equal and the distance between the pairs of bars will also be same. In this way, we will get a double bar graph. Now, if you want to find out which year had the largest difference in the number of boys and girls, then by looking at the lengths of the bar, we can easily tell that difference in number of boys and girls was largest in 2007. Similarly, we can also get different information. Thus, in a double bar graph, two different types of data are represented as pair of bars so that the two sets of data can be compared. The same scale is used for both figures. Like the bar graph, the double bar graph can also be drawn horizontally or vertically. We will understand more about this in the next video. Today we have learned the double bar graph and how to draw it. In the next video, we will see some interesting examples related to this. Today we will see some interesting examples related to double bar graph. The double bar graph shown depicts how the production of rice and wheat in India varied over the years. Find the answers to the following questions with the help of double bar graph. In which year was the highest rice production? Here, the production of rice is denoted with blue bars. The longest length blue bar is for the year 2015-2016. We can say that the maximum production of rice was done in the year 2015-2016. What was the difference between the production of rice and wheat in the year 2013-2014? We see that in the year 2013-2014, rice production is 107 million tons and wheat production is 96 million tons. There is a difference of 107 minus 96 million tons, that is 11 million tons in the production of both. What percentage of wheat production increased in 2015-2016 as compared to 2014-2015? We see that wheat production is 87 million tons in 2014-2015 and 92 million tons in 2015-2016. Increase in wheat production is equal to 92 million tons minus 87 million tons is equal to 5 million tons. Since we are calculating growth in comparison to the production of 2014-2015, we will consider the production of 2014-2015 as the base and express the increase in percentage. In this way, the percentage increase is equal to 5 million tons divided by 87 million tons multiplied by 100%, which is equal to 5.75%. Therefore, wheat production increased by 5.75% in 2015-2016 as compared to 2014-2015. Let's see the next example. The following figures were collected to determine the profits of Dinesh and Ramesh shops. Select the appropriate scale and represent the data shown on the double bar graph. Let us draw the given data horizontally by drawing a double bar graph. First, we will draw two mutually perpendicular lines on the paper, take names of months on the x-axis and profit in lakhs of rupees on the y-axis. For our convenience, we will choose a convenient scale. Like here, we can take 1 unit is equal to 2 lakh rupees. According to the scale, we will show the numbers on the y-axis. We will take this type of bars to show the profit of Dinesh shop and this type of bars for showing the profits of Ramesh shop. Now, we will represent the data as a pair of bars. The profit of Dinesh's shop in the month of January is 5 lakh. Therefore, we will draw a bar up to number 5 on the y-axis. In the same month, the profit of Ramesh's shop is 8 lakh rupees, which we will show by drawing a bar up to number 8 of y-axis. Similarly, we will represent the data for all months. Remember that the width of the bars is kept the same here and the distance between pairs of bars is also kept the same. In this way, we have drawn a double bar graph. Now, can you draw a double bar graph for the marks obtained in various subjects in your last 2 exams? Find out the marks of both examinations. In which exam you have got more marks in mathematics? On this basis, what would you say about your maths performance? Will you be able to tell which subject you need to pay more attention? Today we have seen some interesting examples related to double bar graph. In the next video, we will see some mistakes related to double bar graph. Today we will see some common mistakes related to double bar graph. Mistake 1. A child drew this double bar graph based on the data shown. Can you tell us what is reported here? Think. We cannot tell because this double bar graph does not show which color represent what bar. Because of this, information cannot be obtained from this double bar graph. Keep in mind that it is necessary to show what the bars represent when drawing the double bars. As such, it is necessary to show here that the green bar represents the number of girls and the blue bar represents the number of boys. Mistake 2. Difficulty in getting information from double bar graph. Some children have difficulty in finding out what is reported in double bar graph. For example, if they are asked what is shown in the double bar graph, then they fail to answer it. To find out what information is shown in a double bar graph, it is necessary to see what is represented on x-axis and the y-axis, as well as to understand what each bar represents in a pair of bars. Here, the number of students is shown on the y-axis and the classes are shown on the x-axis. Here, the green bar represents the number of girls and the blue bar represents the number of boys. With this understanding, we can say that the number of boys and girls studying in classes 6 to 10 is shown in the given double bar graph. So today we have learned some important things related to double bar graph. Hope that now you can draw the double bar graph and get information from it. Today we have seen some common mistakes related to double bar graph. Today we will learn grouping of data and histogram. Disha found the age of 40 persons living in her colony, from which she got the following numbers. Such a collection of numbers collected to get desired information is called data. Here, each number is an observation. Information from these figures, such as how many people are above 25, is not easy to find. Therefore, we organize the data in a systematic way, such as by making tables using tally marks. But it will not be easy to do this here because the number of observations here are very large. And if we show each observation in the table, then the table will be very long. In such a situation, we organize observations into different groups. Here, the smallest observation is 5 and the largest observation is 68. Therefore, the range of the data is from 5 to 68. So here, we will create groups of observations like 0 to 10, 10 to 20, 20 to 30, and so on. We call each group a class interval or class. Each class interval has a lower class limit and an upper class limit. Like 0 to 10 has lower class limit 0 and upper class limit 10. By subtracting the lower class limit from the upper class limit of class interval, we get the difference between the two. We call it class width or class size of that interval. For example, the class width or the class size of the interval 0 to 10 is 10 minus 0 is equal to 10. Similarly, the class width of the class interval 20 to 30 will be 30 minus 20 is equal to 10. Similarly, here the class width of all intervals is 10. Now we will represent the numbers in the table in the form of tally marks. Here the observation 5 is included in the class interval 0 to 10. So we will represent it in the table by making a tally mark in the row 0 to 10. Now let's talk about observation 10. We see that 10 is included in class interval 0 to 10 as well as 10 to 20. but an observation can only be included in a single class interval. To avoid this situation, we adopt a convention that a common observation will be presented in the higher class intervals. Here, we will include 10 in higher class interval 10 to 20 and create tally marks for it. So, tell me in which class interval the observation 40 will be included? Think. Absolutely right. It will be included in the class interval 40 to 50 and not in 30 to 40. So, we will create a tally mark in class interval 40 to 50 to represent 40. Similarly, we will present all the data in the table using tally mark. Now here, there are two tally marks in the class interval 0 to 10. Can you tell me, what do you understand from this? Think. Let me tell you, these two tally marks denote observations 5 and observation 8. In this way, the number 2 tells that number of observations that which are included in class interval 0 to 10, that is, there are 2 persons between the ages 0 and 10 years. We call it the frequency of class interval 0 to 10. Similarly, you can write the frequency of all these class intervals in this way. You can see that the sum of the frequencies of all class intervals is 40, which is equal to the number of observations. Thus, this table is completed. This is a frequency distribution table. Since we have classified the data presented, we now call them grouped data, and the obtained distribution is called a grouped frequency distribution. From this table, we can draw a graph as follows. In this graph, the class intervals are presented on the horizontal axis. For example, 0 to 10, 10 to 20, etc. Similarly, the number of persons are represented on the vertical axis. To show this, the scale of 1 unit is equal to 2 persons has been taken. The length of a rectangle drawn on a class interval tells us how many observations occur in that class interval. The number of observations in a class interval is called the frequency of that class interval. For example, the frequency of the class interval 20 to 30 is 6. The bars drawn to show frequency have the same width and the two adjacent bars have no space or distance between them. This type of representation of data is called a histogram. We will understand it better with some examples in the next video. So today we have learned grouping of data and histogram. In the next video, we will see some interesting examples related to them. Today we will see some interesting examples related to grouping of data and histogram. "38 contestants participated in a dance competition. Here are their scores out of 50. Represent them in a frequency distribution table and draw a histogram for the grouped data. To create a frequency distribution table, we will create 3 columns. The first column will show the class interval of the score. The second column will show the tally marks, and the third column will show the number of contestants, which will show the frequency of the class interval. Now, we will choose the class interval. Can you tell me the class interval we can take here? Think. Let me tell you, we see that the smallest observation is 21 and the largest observation is 48. So we have to construct class intervals in such a way that we can represent these numbers effectively. Here we will make class intervals like this. You can see that the class size is same here. You can also create class intervals like this, but from the first method, we can get more clear information. Then we will take the scores one by one and represent it using the tally marks in the appropriate class interval. Here, 25 is included in these two class intervals. Keep in mind that common observation will always be included in the higher class interval. So, 25 will be represented in the class interval 25 to 30. In this way, we will create tally marks for all numbers. After this, we will count the tally marks from which we will find the frequency of the class interval. We will mark it in the third column. In this way, we have made a frequency distribution table. Let us now draw a histogram with the help of frequency distribution table. Draw two mutually perpendicular lines on the paper. The horizontal line is the x-axis and the vertical line is the y-axis. We will show the score on the x-axis. Here, we make a kink sign to state that we are not showing scores from 0 to 20. Here, the difference in the upper class limit and the lower class limit of each class interval, that is, the width or size of each class interval is same. Therefore, we will mark the class intervals by keeping the same distance on the horizontal axis. Similarly, we will show the number of competitors on the y-axis by taking 1 unit is equal to 2 contestants. The greatest frequency in the frequency distribution table is 10. So, we can take the number of contestants on the y-axis 1 unit more than it, that is 12. Now, we will represent the frequency of each class interval in the form of length of the bars. For example, to represent the frequency of the class interval 20 to 25, we will draw a bar whose length will be 7 contestants. Similarly, we will show the frequency of all class intervals. Keep in mind that we will keep the width of the bars equal and will not keep any distance between the bars. Next example, find out by reading the histogram shown. What information does this histogram display? The histogram shows how many hours Class 8 students spend in studies. Find the number of students studying for 4 or more hours. Here, two class interval 4 to 6 and 6 to 8 represent the number of students who study more than 4 hours. Looking at the class interval 4 to 6 and the length of the bar drawn above it, it can be understood that there are 20 students who study 4 or more than 4 hours but less than 6 hours. Similarly, the class interval 6 to 8 and its length of bar shows that there are 5 students who study 6 or more hours but less than 8 hours. In this way, the number of students studying for 4 or more hours is 25. So today we have seen some examples related to grouping of data and histogram. In the next video, we will see the misconceptions and simple mistakes related to them. Today we will see the misconception and common mistake related to grouping of data and histogram. Misconception 1. In which class interval the observation 30 can be included in the given frequency distribution table? In the frequency distribution table, children easily classify observations that are not common to two class intervals, but when they find an observation that is common to two class intervals, they cannot classify it. For example, if we want to classify 30 here, children get confused to decide if they should keep 30 in class interval 20 to 30 or in 30 to 40. In such a situation, some children think that it should be kept in lower class interval. So, they give option 1 as answer, which is a wrong answer. In case of common observation, we follow a convention that common observation will be represented in upper class interval. Here, we will put 30 in the upper class interval, 30 to 40, but not in 20 to 30. Hence, option 2 is the correct answer. Mistake 1. If children are asked to find the frequency of 2 in the given observation, then some children do not understand the meaning of frequency, so they are unable to answer this question. The number of times an observation occurs in a group of observations is called the frequency of that observation. Here, we see that observation 2 has occurred 6 times in the group of given numbers. So, we can say that the frequency of 2 is 6. So, today we have seen the misconception and common mistake related to grouping of data and histogram. Today we will learn about pie chart. Let us understand pie charts with an interesting example. Meena has planted some flower plants in the courtyard of her house. Every day she collects flowers. Today she has collected jasmine, marigold and rose flowers. Their number are as follows. Let's represent this information in an interesting way. The total number of flowers here is 30 plus 20 plus 10, which is equal to 60. Here, the number of jasmine flowers is 30, which is 30 by 60, that is half part of the total number. Similarly, the number of marigold flowers is 20 by 60 part of the total number, that is 1 by 3 part, and the number of rose flowers is 10 by 60, that is 1 by 6 part of the total number. We would consider the value of an entire circle to be 60 flowers. Since the central angle of an entire circle is 360 degree, we can say that 60 flowers represent the central angle of 360 degree. The number of jasmine flowers is 1 by 2 part of the total 60 flowers. We will represent this number from a sector of a circle whose central angle is 1 by 2 multiplied by 360 degree, which is equal to 180 degree, that is half circle. Similarly, the portion of marigold flowers can be represented by making the sector with central angle of 1 by 3 multiplied by 360 degree, which is equal to 120 degree, and the portion of rose flower with a central angle of 1 by 6 multiplied by 360 degree is equal to 60 degree. Here we have represented the division of total number of flowers in the form of various sectors of the circle, a representation in which the data is represented by the sectors of the circle is called a pie chart. A pie chart tells us the relation of a whole to its part. For example, for 30 jasmine flowers, the total number of flowers is 1 by 2 of the total 60 flowers. Likewise, for 10 roses, the total number of flowers is 1 by 6 part of the total number. And 20 flowers of marigold, it is 1 by 3 of total number of flowers. At the same time, the pie chart also helps us to compare in different parts. For example, it can be said that the number of marigold flowers is double and the number of jasmine flowers is triple as compared to the number of rose flowers. The central angle of each sector in a pie chart is proportional to the information represented by it. For example, the central angle representing the number of jasmine flowers is in proportion to the number of jasmine flowers. In this way, the total number is fixed, and if the number of jasmine flowers increases, then the size of the corresponding sector will also increase. Or conversely, if the number of jasmine flowers is less, then the size of the corresponding sector will also decrease. Just think, can we use the unitary method to find different central angles? Let me tell you. We know that the central angle of an entire circle is 360 degrees. So, we can say that 60 flowers represent the central angle of 360 degrees. In this way, one flower can be represented with a central angle of 360 degrees divided by 60 is equal to 6 degrees. Now, the number of jasmine flowers is 30. So, we can represent this number by 30 multiplied by 6 degrees, which is equal to 180 degrees. In the same way, you can get different central angles using the unitary method. Today we have learned to make pie charts. In the next video, we will see some more interesting examples based on pie chart. Pie chart. Pie chart. Today we will see some interesting examples related to pie chart. There is a zoo near Mohit's village. There are 720 different types of animals in the zoo. The details of their numbers are displayed in the pie chart shown. Understand the information and answer the following questions. Which animal is lowest in number? We know that the central angle of each sector in a pie chart is proportional to the information it represents. Thus, larger the central angle, the greater is the number represented by it. Or, the smaller the central angle, the smaller is the number represented by it. Here, we see that the smallest central angle is 20 degrees, which represents the number of tigers. We can say that the zoo has the lowest number of tigers. Find out how many elephants are there in the zoo. A total of 720 animals are represented here from a central angle of 360 degrees. In this way, 720 divided by 360 animals can be represented from a central angle of degree 1. Since the number of elephants is denoted by 40 degrees, therefore, from a central angle of 40 degrees, 720 divided by 360 multiplied by 40 elephants, that is, 80 elephants are represented. That's why there are 80 elephants in the zoo. Find the difference between number of deers and the reptiles. We know that the central angle of each sector in a pie chart is proportional to the information it represents. In this way, difference in central angles representing deers and reptiles will be proportional to the difference in the number of deers and reptiles. Hence, the difference in the central angles of the two is 100 degrees minus 80 degrees is equal to 20 degrees. Since 720 divided by 360 animals can be represented by a central angle of degree 1, hence 720 divided by 360 multiplied by 20 is equal to 40 animals can be represented by a central angle of 20 degree. In this way, we can say that there is difference of 40 animals in the number of deers and reptiles. Next example, the sale of various electronic items sold from Ankur's shop in a year is given below. Can you represent this information in the pie chart? Try it. We have to find the central angle of sale of each item to draw a pie chart. To find the central angle, we will first add the number of all sold items. 48 plus 24 plus 96 plus 120 is equal to 288. We will consider this as a whole. Therefore, in the pie chart, an angle of 360 degree at the center of the circle will represent the number 288. Now, let's find the central angles representing the number of each object. The number of TV sold is 48 divided by 288 part of whole, that is 1 by 6 part. Therefore, the central angle denoting it will be 1 by 6th part of 360 degree, that is 60 degree. So, what will be the central angle to represent the number of refrigerators? Think. Absolutely right. Since the number of refrigerators is 24 divided by 288 part of whole, that is 1 by 12 part, hence the central angle representing it will be 1 by 12 part of 360, that is 30 degree. Similarly, we find other central angles and draw a table. Now, we will show these data in the pie chart. Thus, we have drawn a pie chart to show the information. So today we have seen some examples related to pie charts. In the next video, we will see some mistakes related to this topic. Today we will see some misconceptions and mistakes related to pie chart. Misconception 1. Amit's earning is rupees 24,000 and Sameer's earning is rupees 15,000. They spend some part of their earnings and save some part of it as given below. Can you find who saves more money? Stop the video and try to find it. Here, how much money Amit have saved is represented by an angle of 60 degree and the amount of money that Sameer have saved is represented by an angle of 90 degree. Some children compare angles to find that Sameer saves more money than Amit. With this understanding, they answer option 2, which is a wrong answer. They do not see the pie chart as a whole and its parts. Here, the total earnings are denoted by whole circle. In this way, the angle representing the savings made by Amit is 60 degree divided by 360 degree is equal to 1 by 6 of the whole circle. In pie chart, since the central angle of the sector of a circle is proportional to the information represented by it, we can say that here savings made by Amit is 1 by 6th of his earning. That is, savings made by Amit is 1 by 6 multiplied by 24,000 rupees is equal to 4,000 rupees. In the same way, can you find how much savings Sameer will make? Stop the video and try finding it. Let me tell you, savings made by Sameer divided by Sameer's earning is equal to 90 degree divided by 360 degree is equal to 1 by 4. In this way, the savings made by Sameer is 1 by 4 multiplied by 15,000 rupees is equal to 3,750 rupees. So, who saves more money? Absolutely right. Amit saves more money. Hence, option 1 is the correct answer. Misconception 2. 40 students study in Mandeep's class. One day, 5% of total 40 students could not come to school due to illness. If we want to represent the number of students present and absent in the pie chart, can you find the central angle of the sector in the pie chart to represent the number of absent students? Some children do not understand what is given in the question. They take the number of absent students as 5 and calculate central angle 5 by 40 multiplied by 360 degree is equal to 45 degree to represent absent students. They give option 2 as an answer, which is a wrong answer. Here we are given the percentage of absent students. 5% means 5 students are absent in every 100 students. In this way, 5 divided by 100 multiplied by 40 is equal to 2 students out of 40 students. If we represent the total number of students, that is 40, in the form of a whole circle, then the central angle of the sector to represent the number of 2 students is 2 divided by 40 multiplied by 360 is equal to 18 degree. So, the correct answer is option 1. Now, let us see a mistake that happens while making a pie chart. While making the pie chart, children forget to show what information is being represented by different sectors. Because of this mistake, what is represented by the sector cannot be determined and it makes it difficult to get information. Therefore, it is necessary to write the information represented by them on all the sectors of the pie chart. So today we have seen some misconceptions and mistakes related to pie charts. Today we will learn about chance and probability. Suppose you are playing a game of snakes and ladder with your friend. You have to walk only 3 places to win and it is your turn to throw the dice. If you throw the dice, will you get the number 3? Think. You cannot say with certainty whether you will get the number 3 or not. But there is a possibility or chance of getting 3. Can you tell me what is the chance of getting 3 in this situation? Think. Let me tell you. Throwing the dice is an experiment which can have outcome 1, 2, 3, 4, 5 or 6. We say that in the experiment of throwing a dice, the total number of outcomes is 6, since we are required to get 3. Therefore, the number of desired results, that is, the number of favorable outcomes is 1. In this way, we can say that the number of favorable outcomes is 1 out of all 6 outcomes. This is why we say that the probability of getting a favorable outcome is 1 out of 6, that is 1 by 6. To know the probability better, let's understand some of the terms used in its context. An experiment in which more than one result is possible and the result cannot be accurately predicted is called a random experiment. Can you give any example of a random experiment? Think. Let me tell you, tossing a coin, getting a candy from the candy box without looking into it, etc. are all the random experiment. Can you tell me if the experiments like to taste the sweets and find if it is sweet or not, to drop the stone from a certain height and see if it hits the ground or not, are also random experiment? Think. Sweets will always be sweet. Similarly, if anything falls from some height, it definitely comes to the ground. That means, in such situation, we know in advance the result of such experiments. Therefore, we cannot call them random experiments. Now think, if we toss a coin, whether the chance of getting a head will be greater or the chance of getting a tail will be greater. Think. On tossing a coin, the chance of getting a head is equal to the chance of getting a tail. We say that the outcomes are equally likely. Now imagine if we write numbers 1, 2, 3, 4, 5 and 6 on the faces of a matchbox and toss the matchbox. Will the probability of getting each number in this case be equal? Think. You are right. Since the size of faces of the matchbox are different, the probability of getting each digit will also be different. Therefore, here the outcomes cannot be equally likely. Each outcome of an experiment or a collection of outcomes make an event. For example, when we rotate a dice, then in this random experiment, getting one of the outcomes from 1, 2, 3, 4, 5 or 6 is an event. Similarly, getting a number which is greater than 3 or getting an even number is also an event. Let's talk about the event of getting a number greater than 3. Here, favorable outcomes are 4, 5 and 6. In this way, there are 3 results of the occurrence for the event of getting number greater than 3. But any number 1, 2, 3, 4, 5 or 6 can come up in this experiment. So, here the total outcomes are 6 for the event of getting number greater than 3. The probability of an event is the ratio of the number of favorable outcomes of the event to the total number of outcomes in the experiment. Here, the probability of getting a number greater than 3 will be 3 by 6 is equal to 1 by 2. If the event is certain, for example, getting any number from 1 to 6 on the dice, then the probability is 1. And if the event is impossible, like getting the number 7 on the dice, then the probability is 0. But when an event is likely to occur, such as obtaining a number greater than 3, then the probability is greater than 0 but less than 1. In this way, the probability of any event can be 0 or more than it, but 1 or less than it. Now, let's look at some situations related to use of chance and probability in real life. During elections, people are asked about their choice. The number of answers received is used to find the probability of winning of each candidate, and exit polls are obtained based on it. Suppose your elder brother has got 85% marks in a government examination. If last time 1,800 students have been selected out of 2,000 candidates who have secured 85% marks, then we can say that the probability of selection of your brother is 1,800 divided by 2,000, that is 9 out of 10. Now, you can find out more such situation by yourself. Today we have learned about chance and probability. In the next video, we will see some interesting examples related to them. Today we will see some interesting examples related to chance and probability. There are some paper slips in a box on which numbers from 11 to 17 are written. If a slip is taken out of the box without looking at it, what will be the probability of getting an even number on the slip? There are a total of 7 slips in the box on which one of the numbers from 11, 12, 13, 14, 15, 16 or 17 have been written. So, if one slip is taken out of the box without looking at it, we will get a number from these numbers. That is, the total number of outcomes of the experiment is 7. Here, getting an even number is an event. Since the even number can be 12, 14 or 16, we can say that the number of favorable outcomes for the event are 3. Probability of an event is equal to the number of favorable outcomes for that event divided by the total number of outcomes of the experiment. Therefore, the probability of getting an even number on the slip drawn will be 3 by 7. Next example, Harsh bought 10 lottery tickets. If a total of 4,500 tickets were sold in the lottery, what would be the probability of winning the lottery by Harsh? The total number of lottery tickets are 4,500. The probability of selection of each lottery ticket is equal. We can say that the total number of outcomes of the experiment are 4,500. Of these, Harsh has bought 10 tickets. In this way, Harsh can win the lottery if one of the 10 tickets will be selected. In this way, there are 10 favorable outcomes for the event of winning the lottery by Harsh. We know that the probability of an event is equal to the number of favorable outcomes for that event divided by the total number of outcomes of the experiment. So here, the probability of winning the lottery by Harsh will be 10 divided by 4,500 is equal to 1 divided by 450. Next example, suppose you have 3 coins. What will be the probability of getting heads on the 2 coins and tails on the 1 coin if all 3 coins are tossed together? When we toss 3 coins together, the outcomes are as follows. The total number of outcomes of the experiment when tossing 3 coins together is 8. We have to find the probability of getting heads on the 2 coins and a tail on 1 coin. Can you tell me what are the favorable outcomes in this situation? Think. Absolutely right. There are 3 situations when we will get 2 heads and 1 tail. That is, the number of favorable outcomes in this experiment is 3. Since the probability of an event is equal to number of favorable outcomes divided by total number of outcomes of the experiment, therefore, the probability of getting heads on the 2 coins and tail on the 1 coin is 3 by 8. So today we have seen some interesting examples related to chance and probability. In the next video, we will see some common mistakes related to them. Today we will see some common mistakes related to chance and probability. Mistake 1. Believe that the number of favorable outcomes of an event is the probability. Some children believe that the number of favorable outcomes of an event is the probability of that event. For example, if children are asked, if two coins are tossed at the same time, what is the probability of getting heads on the both coins? Some children think that the outcomes are HH, HT, TH or TT, in which favorable outcome HH is only 1. Therefore, children say that the probability of getting heads on both coins is 1. This is a misunderstanding. The correct understanding is that the total number of outcomes of the experiment for the event of tossing two coins is 4, and the number of favorable outcomes for the event of obtaining heads on both coins is 1. So, the probability of getting a head on both coins is 1 out of 4, that is 1 by 4. Mistake 2. Understanding that the probability could be greater than 1. Some children think that the probability of an event can be greater than 1. But this is a misunderstanding. The probability of an event can be 0 or greater than it or 1 or less than it. Mistake 3. Outcome of a random experiment can be controlled. Some children make the assumption that they can achieve the desired outcome in the random experiment. For example, they think that if they keep head on top and toss the coin, they can get the desired outcome. Similarly, they think if a dice is thrown with a specific force, the desired number can be obtained. Remember, in the context of fair dice, the result cannot be controlled. So, the outcome cannot be predicted precisely. Also remember that if the dice is not fair, then the desired outcome can be obtained. But in such case, we cannot call the experiment a random experiment. Mistake 4. Treating all outcomes as equally likely outcomes. If we tell children that there are 15 slips in a box in which number 1 is written on 10 slips and number 2 is written on 5 slips, if one slip is drawn from all the slips at random, whether the possible outcomes are equally likely? Children think that the number written on the slips is either 1 or 2. Hence, the outcome will be one of these number. Therefore, they think that the probability of getting each number is equal, that is, the result is equally likely. But this is a misunderstanding. Here, number 1 is written on 10 slips and number 2 is written on 5 slips. So, the probability of getting 1 is greater than the probability of getting 2. Therefore, the possible results in this situation may not be equally likely. Mistake 5. Lack of understanding of equally likely outcomes. Some children think that it is difficult to get 6 by throwing the dice, while it is easier to get a number smaller than 6, such as 2. This is a misunderstanding. The probability of getting 1, 2, 3, 4, 5 or 6 of these points on throwing the fair dice is equal. So, the probability of getting 6 is as much as the probability of getting 2. So today we have seen some common mistakes related to chance and probability.